for the rest of this. The next part of this investigation is your mineral analysis of the minerals in granite. We're trying to figure out what minerals make up this rock. We've got spaces for 5 minerals. That does not mean that there are 5 minerals in here, okay? So there are your mineral tests, the properties. You can test the properties of the minerals in here with the pieces in your Petri dish. And it says to use a probe to separate the pieces. Your probe is your pencil or your finger. If you cannot find good samples in there, you are just consider this is crushed granite. These are not isolated minerals. You should find several pieces of the different types, but if there's some that you want to observe and it's in a clump, just observe it in that clump if you want to. They don't have to be absolutely separate pieces. If you want to search for more, here's some more crushed granite, and the Miracle Grow box has some crushed granite too. So seek out the cashews and the Miracle Grow, all right? So with your group, work through data table 3.2 and complete the analysis and conclusion questions. We're going to spend about 30 minutes on this. So at 5 till 9, we will convene with the investigation, okay?
Sterilized doesn't mean clean.
And I'm sure they're not been sterilized either because they can see mold.
Okay, guys, listen. A couple of people have had the same question, so I'm going to address it publicly. The question was, Quentin, would you reiterate that?
Okay. When you're looking at rocks versus minerals, with minerals you look at cleavage and fracture, you observe cleavage and fracture. I was wondering if, because it's a rock and it's a mixture of minerals, if that is something as well, because when I look at it, there are a lot of flat planes on the pink mineral, but then there are other parts where there are no flat planes, so there's a mixture
Okay.
of cleavage and fracture.
That's a good question. And because these are not isolated minerals, you have to observe the broken piece of the rock. You still observe the cleavage and the fracture. Out in the field, you'll crack off a piece, look at that broken piece, and observe the different minerals and the cleavage and fracture of each of the different minerals.
Would you define the difference between a rock and a mineral? I still hear questions about confusion about this is a rock or a mineral or what.
I think Mira Lou defined it beautifully. She said that a mineral was only one identifiable substance. A rock is a composition of 2 or more minerals. Minerals can grow into huge pieces though. So you may have a hand sample that is just one mineral that came from a bigger rock, right? So if this room were one big boulder and we had crystals that were as big as each of us, and we took a hand sample of that, could we get a combination of all the different minerals that represented this huge rock? No, we could not. In one hand sample, the odds of us getting a representation of all of the different minerals, if this is the crystal size, are very slim. I'm a crystal, you're a crystal, we're all crystals. Well, the crystal's not here.
So basically, it's like chocolate chip is the mineral, and the whole cookie is the rock.
Yes, you're exactly right.
Okay, I know we're not typically doing teacher talk, but what you saw was the need to go back to fundamentals. And I asked for that because I heard at least 2 people, it was not clear. So that said, okay, it's time to stop, go back to whole class instruction, and go back to the fundamentals.
Yes.
I understand the definitions. My confusion is, where did it, if it comes from igneous, and when magma cools and hardens, everything's black, it's obsidian, and
No.
not all.
Why do you say that?
It just looks all appears.
When magma cools and hardens? Have you seen magma cool and harden?
Not in person, but on TV. So I'm just thinking like
Okay,
a
so wait, let me think. As magma cools and hardens, as viewed from TV, where does that camera have to be?
Right
On the surface.
Can you see is the video camera?
there. No, lava, I'm sorry.
Okay, when lava cools and hardens, you're right, it is black.
So where does the mineral of feldspar, for instance, appear that it's the color, and then the other minerals that we.
Okay.
So how do we get this if,
So do you think that came from a lava flow that cooled?
It had to, because it's igneous.
Can you speak?
Or, so she's saying that because it's igneous, it had to come from a lava flow, right? Is that what you're saying?
That's what I'm assuming from the fact that I know that igneous rocks are coming from the cooling of lava.
Okay. Do all magma chambers, all magma that cools, does it have to come to the surface and flow out on the surface to cool?
No.
Okay.
So are you saying that it only happens underground, not on the surface?
Only?
Well,
Some.
that?
Some
That?
of them. Some of the minerals, right?
Yes.
It just depends. Because when I'm thinking of magma, I'm thinking of everything, it's all mixed together, and then it just separates itself out when it cools.
Mhm. And we're going to look at the cooling rate and how that affects those crystals later. So that's a really great question. I want you to tuck that in your pocket, and we're going to answer that in a little bit. Okay? Yes.
I don't know if I'm gonna get too much, but originally the whole earth was molten. And so some of these rocks, we
Wait a
date
minute.
them.
Why was the whole Earth molten?
When it was formed in space.
Was it molten?
Yeah, I think it was. It was supposed to. I don't know.
I don't know. I haven't
Cosmology
heard
said
that.
it was, but we. And I mean, they date some of these rocks, some of the oldest ones they find is how they're determining the age of the Earth. So some of the oldest rocks may have been here since the Earth originally formed. And so they were from the original cooling, but most of them have been recycled many times.
I'm gonna have to look into that. I'm not.
Yeah, I'm not
totally
really
sold
sure
on it.
either, but I know they find some rocks that they were from the early, original cooling.
Yes.
So, a mineral is like one solid
Brandon, can you
looking-
speak up, please?
Oh, so a mineral is like one solid looking piece of.
One
like
solid
it- Is it one, it looks exactly the same throughout, it's a mineral.
Yes. You're not saying that is a mineral.
No,
Yes.
it's the rock,
in
multiple stuff.
Right,
But
that,
that
this
piece
is
of
a
mineral.
mineral because it's all the same, it's the
All
same
one
substance.
piece.
That whole thing right there is all halite. This is all potassium feldspar. This is all biotite. So now, if you take these and you put them all together and they grow together and lithify, then you could get this, okay?
Solid substance.
One substance, Okay, so let's go through these characteristics and let's determine what these minerals are in your granite sample. And a little hint, everything that's in here, you determined the name of yesterday, all right? So use your mineral tests to determine which minerals are in that hunk of granite.